For centuries, the Great Pyramid of Giza and its surrounding complex have captivated the imaginations of people worldwide. As one of the 7 wonders of the world, this ancient marvel has been the subject of extensive study and speculation. While much has been learned about the construction and purpose of the pyramids, one question has long puzzled researchers. Why were they built in such a seemingly inconvenient location, kilometers away from the life-giving Nile River? Recent discoveries have shed new light on this mystery, revealing that the answer may have been hidden just beneath the desert sands all along. This article explores the groundbreaking research that has uncovered a lost branch of the Nile, offering fresh insights into the geography of ancient Egypt and the construction of its most iconic monuments. The Giza Pyramid Complex, an enigma in the desert. The Giza Pyramid Complex is far more than just the Great Pyramid. It encompasses 3 main pyramids, the Great Sphinx, several smaller pyramids, various temples and other structures. Built between approximately 2575 and 2465 BCE, this vast complex served as both tombs and temples for the ancient Egyptian pharaohs. However, its location has long perplexed historians and archaeologists. It lies about 7 kilometers west of the Nile River. It's situated roughly 10 kilometers from Memphis, the capital of Egypt at the time. This positioning seemed impractical, especially considering the immense logistical challenges involved in constructing such massive monuments. The ancient Egyptians sourced materials from far and wide: copper from the Sinai Peninsula, timber from Lebanon, granite for the exterior from Aswan far up the Nile. Historical evidence, including papyri from the Sinai Peninsula, indicates that the Egyptians used barges to transport heavy building materials down the Nile. It was speculated that they might have created artificial waterways to bridge the gap between the river and the construction site. However, the creation of over 7 kilometers of canals seemed an extraordinary undertaking, leading to the persistent question: why choose this particular location? Uncovering the hidden waterway. The answer to this long-standing mystery has emerged through the application of modern technology and innovative research methods. A team of scientists employed radar satellites to peer beneath the surface of the desert, revealing a landscape hidden for millennia. Key findings of the research include discovery of subtle depressions. The satellite imagery revealed tiny depressions in the landscape, previously obscured by nearby farmland. Subsurface analysis. Researchers took samples from more than a dozen meters below the surface, finding sand at the bottom layers. Interpretation of geological evidence. The presence of sand in deeper layers typically indicates the historical presence of running water, as sand is usually only the top layer in a desert environment. By combining the channels observed in satellite imagery with the geological evidence from subsurface samples, researchers reached a groundbreaking conclusion. Thousands of years ago, a branch of the Nile flowed through the area, running parallel to the main river but several kilometers to the west. This newly discovered waterway has been named the Aramat Branch, which appropriately means pyramid branch in Arabic. The significance of this discovery extends beyond the Giza complex. Researchers were able to track a 64-kilometer stretch of this former river. Along this stretch, they identified 31 pyramids in addition to those at Giza. This revelation suggests that the Aramat branch played a crucial role in the placement and construction of many of ancient Egypt's most important monuments. The Aramat branch, a lifeline for ancient Egypt. The discovery of the Aramat branch provides new insights into the development of ancient Egyptian civilization. Key points include time span of activity. The pyramids along the Aramat branch were constructed over a 1,000-year period, from approximately 2600 to 1600 BCE. Significance for settlement. The presence of this waterway likely influenced the location of settlements and the development of infrastructure in ancient Egypt. Transportation and logistics. The Aramat branch would have facilitated the transportation of building materials and supplies, making the construction of the pyramids more feasible than previously thought. Agricultural implications. The river would have provided water for irrigation, supporting the agricultural activities necessary to sustain the large workforce involved in pyramid construction. The disappearance of the Aramat, a tale of climate change. The fact that this significant waterway has been hidden for thousands of years raises an important question. What happened to the Aramat branch? The answer lies in the broader climatic and geological changes that have shaped the Nile River Valley over the past 14,000 years. Key stages in the region's climatic history include the African humid period circa 14,000 years ago. The Eastern Sahara was significantly wetter than it is today. Large river systems and lakes were present. The region resembled a savanna or grassland rather than a desert. The Nile River Valley was largely inhospitable due to extensive swamps and marshes. Transition period 6,000 to 10,000 years ago. Gradual drying allowed human settlements to move closer to the riverbanks. Dramatic shift, approximately 5,000 years ago. Decreased rainfall led to sediment buildup in the Nile floodplain. Creation of dry farmland above the marshes. Further drying of the Sahara pushed settlements closer to the Nile. The era of the Aramat branch. Conditions were still wetter than present, allowing multiple Nile branches to thrive. The Aramat supported the construction of pyramids and the development of settlements along its banks. The gradual disappearance of the Aramat branch was likely due to a combination of factors. Tectonic shifts. Changes in tectonic plates tilted the ground, making the Aramat branch uphill from the main Nile. Sediment accumulation. Wind-blown sand and riverborne sediment gradually filled in the river channel. Continued climate change. Overall drying of the region reduced water flow in secondary river branches. These factors combined to cause the Aramat to run dry, eventually disappearing beneath the desert sands and remaining hidden for millennia. Implications for Egyptology and archaeology. The discovery of the Aramat branch has significant implications for our understanding of ancient Egyptian civilization and opens up new avenues for research. New archaeological sites. By following the path of the former river, archaeologists may discover previously unknown historical sites. Improved preservation efforts. Knowing the location of the Aramat can help in identifying and protecting potential archaeological sites along its former course. Enhanced understanding of cultural development. The river provides new insights into the interconnectivity of ancient Egyptian settlements and trade routes. Revised perspective on ancient logistics. The presence of the Aramat explains how the ancient Egyptians could transport massive building materials to seemingly remote locations. Climate change studies. The history of the Aramat offers valuable data for understanding long-term climate change in North Africa. Conclusion. Unveiling the secrets of the sands. The discovery of the Aramat branch demonstrates that even after thousands of years of study, the ancient world still holds many secrets. By combining modern technology with traditional archaeological methods, researchers continue to uncover new information about one of the world's most fascinating civilizations. The lost river of the pyramids not only solves the mystery of the Giza complex's location, but also opens up new questions about the extent and nature of ancient Egyptian settlements. As we continue to explore the hidden landscapes of the past, we gain a deeper appreciation for the ingenuity and adaptability of our ancestors. The story of the Aramat branch serves as a reminder of the dynamic nature of our planet's climate and geography. It highlights the profound impact that environmental changes can have on human civilization, offering lessons that remain relevant in our current era of climate change. As research continues, who knows what other secrets may be buried in the sands of the Sahara? The discovery of the Aramat branch is likely just the beginning of a new chapter in our understanding of ancient Egypt, promising exciting developments in the fields of archaeology, geology, and climate science for years to come.